Hello students, welcome back to our channel Diksha Karnataka. So as you know, we have already started a series where we are discussing on how to study a chapter, right? I am telling you like what formulas you should revise, what concepts you should read and what type of questions are asked from that chapter. So we have already done this for two major topics like solutions and kinetics. So in today's video, we'll be doing one of the most requested topic, that is electrochemistry. Okay. So it is a very high weightage topic and you can expect 2 to 3 questions from this topic. Okay. So now let us start. First is, see, many students have confusion in this chapter. So you should have a broad division like what are the topics in this chapter we are going to study. So first is type of cells. Okay. In this we'll be discussing what are the type of cells that are present. Next we have conductance. All the formulas I'll be discussing, what questions are asked I'll be discussing. So conductance is the next broad topic. So there are many subtopics in between this also. So broadly it is like 3 topics, and then we have commercial batteries. Okay. So please keep this in mind that we have one topic, type of cells, then we have conductance, and next we have commercial batteries. So now coming to type of cells. See, there are 2 type of cell. One is your galvanic cell and another is electrochemical cell. So galvanic cell is the one which converts chemical energy to electrical energy. So what does that mean? It means like any chemical reaction will happen, whatever energy is produced in that reaction, that is converted to electricity. And this is spontaneous process. So what do you mean by spontaneous process? It is like it will happen on its own. We don't need to initiate it. So what will be the delta G for this reaction? It will be negative or less than 0. Right? So you have to remember these 3 points, that what does a galvanic cell do, which energy to which energy it is converted, it is a spontaneous process, and delta G is negative, right? Now coming to your this is electrolytic cell. So we have next one is electrolytic cell. Here what is happening? It converts the electrical energy to chemical energy. Means we will be providing a reaction for this reaction to happen. We have to provide the electricity, as a result of which one chemical reaction takes place. So, and this is a non-spontaneous process because we have to provide electricity. So that is why it is a non-spontaneous process, and delta G will be greater than 0, right? So these are the 2 type of cells. Now, so you can see a small difference between these two. So just keep this diagram in your mind. We have this in galvanic cell there will be 2 containers, and in electrolytic cell there will be 1 container where all the reactions can happen. Now in this, anode is negative, why and all we'll discuss. These points you have to remember. Cathode is positive, whereas in electrolytic cell anode is positive and cathode is negative. And the rest 2 points I've already discussed. Spontaneous reaction, so delta G is negative here, and non-spontaneous, so delta G will be positive here. Now does not require any external source because it is a spontaneous process. Here it requires an external source. So see, these all difference between points can be asked as 1 marker questions in your KCET exam. So you should remember this difference, and this diagram should be in your mind. Okay. Now see, after completing this whole video, I'll come back to this so that we can have a quick revision of all the topics that we have studied. So now let us see the topics under galvanic cell. So I hope you are clear till now what we have discussed. First we have discussed type of cells, right? In the type of cells we are having 2 types. One is galvanic cell and another is electrolytic cell. Now in galvanic cell, what all things we are going to study, that I will discuss here. Okay, so just the list of topics, then we'll go in detail. So first is working of a Daniell cell. So this is Daniell cell is an example of galvanic cell. So we'll study what is the basic principle here. Next is your cell notation. Then we have electrode potential. What is electrode potential? How it is measured? That we'll see. Next we have cell potential. How to calculate it? Nernst equation. What is cell potential and what is Nernst equation difference? Then we have equilibrium constant and Nernst equation relation. And then we have relation between E0 and delta G. So I'll not be covering the whole detail of these topics, but I'll be explaining how to prepare this in the exam point of view. Okay. So now coming to working of a galvanic cell. See here nothing much you have to know. Just see, we will take 2 containers. Okay. First point is there should be 2 containers. One side, always remember, left side will be having your oxidation. Okay. So this is by convention. Okay. And right side it will be taking reduction. So what happened here? This metal undergoes oxidation, as a result of which, so which is the metal taken here? Zinc, right? So zinc undergoes oxidation, gives you Zn2 plus and 2 electrons. So now where are these electrons? These electrons are on this rod. Okay. Now these electrons flow from the outer circuit and reaches on this electrode. Now in this solution, what happens? We have copper 2 plus ion from the copper sulfate solution. This copper 2 plus ion takes these electrons and get reduced. So first of all, you should know what is oxidation definition, loss of electron, and what is reduction definition, gain of electrons, right? So this point, I think we have studied in our previous chapters also. So this is clear. So what is happening on the left side? Zn will give Zn2 plus by releasing 2 electrons. These electrons will come to the electrode, move through the circuit, reaches here, copper 2 plus in the solution will gain those electrons and will get reduced, right? This is the reduction reaction. This is the oxidation reaction. Now we can say, see here in the point when I discussed the difference between, I told you that anode is negatively charged, right? This is because electrons are present here. Now from here electrons are lost, right? So that is why this is positive charge and this is negative charge. So this much, no questions are asked from this, but you have to know how does it work so that we can solve the numericals. Okay. Next is what is cell notation. See here, whenever I want to tell you about cell, it is not possible that every time we have to draw this diagram. So there is a simple trick, or there is a mechanism followed to write the cell notation. So what is it? First of all, you have to start from the left hand side. Which rod is this one? Zinc rod. Okay. Then zinc rod is in contact with what? Zinc sulfate solution. So just write a slash and then give you Zn2 plus. Now you see this Zn2 plus is contact in salt bridge. So you have to put a double 2 lines for representing salt bridge. Then the salt bridge is in contact with copper sulfate. So what is the ion from here? Copper 2 plus, and then copper 2 plus is in contact with copper rod, right? So this is how we represent a cell notation. Now if this ZnSO4 solution has some concentration other than 1 molar, then we have to represent the concentration here. Similarly, if copper 2 plus has the concentration other than 1 molar, the concentration of copper 2 plus should be represented here, right? So that is how a cell works and how the cell is represented. Now we will go to the third topic under this, how to calculate the cell potential. Now you see there is here some potential is generated and here this potential is generated. So the potential generated here is called as oxidation potential, and the potential generated here is called as reduction potential. So what is the EMF of this cell, or what is the voltage of the cell? So the formula to calculate this is E naught of cathode minus E naught of anode, or E naught of right minus E naught of left. So here one thing you have to remember, that this potentials are your reduction potentials. Okay, these both are your reduction potential. So E naught of cathode minus E naught of anode. Now we will discuss what is this reduction potential and that topic. So see here, what is electrode potential? Very simple thing. When you take a, I'll take the example zinc rod with zinc sulfate, right? So what I told you, zinc comes out as Zn2 plus and leaves electron here, right? So you can see here there is a charge difference between the electrode and the electrolyte. So electrode is your negative charge and the electrolyte is having positive charge. So due to this charge difference, one potential is generated here. This potential is called as electrode potential. Okay, so here since Zn is undergoing oxidation, this is called as oxidation potential. Now see the other side where we have copper rod. So if we see here, if the copper rod is taken and you have copper rod with copper 2 plus solution, so what is happening? Electrons are coming out, right? So here also one charge is developed between the rod and the solution present outside. So due to this, the potential developed is called as your reduction potential. Okay, now let us quickly see here. At each electrode electrolyte interface, so at each electrode and electrolyte interface, there is a tendency of the metal ions from the solution to deposit on the metal electrode, trying to make it positively charged. So there are two things, either the metal will get deposited on the rod or the metal will come out of the rod. There are two tendencies. So if metal is coming out, then we get oxidation potential. If the metal is getting deposited, then it is called reduction potential, right? So at the same time, metal atoms of the electrode have a tendency to go into the solution as the ions leaving behind the electrons, and they are negatively charged, right? So as I told you, there are two types of thing happening. Either the metal is coming out of the electrode, giving charges to the electrode, or the metal is getting deposited to the electrode. So this potential difference between the electrode and the electrolyte is called as your electrode potential. Very simple thing, we need not know that much. You have to just think, whenever there is one electrode and an electrolyte, charge difference is generated, due to which potential is generated, and that potential is called as electrode potential. Now then, what is your standard electrode potential? Now see, if the electrolyte concentration is 1 molar or unity, you can say it is 1 unit, then we call the electrode potential as standard electrode potential. Now from this last point is very important, we get many questions from here. The electrode potential is directly proportional to concentration. Okay, so suppose we have 1 molar and another concentration you take 2 molar. So the electrode potential in 2 molar will be higher, right? So the electrode potential is directly proportional to the concentration of the electrolyte. Now coming to next thing, how will you measure the electrode potential? So what just we have to do, one side we will take hydrogen electrode, okay, and hydrogen electrode potential is considered to be 0, just as a convention. Now suppose I want to measure what is the electrode potential of zinc. So I will keep zinc with against the hydrogen electrode, and then we will read the voltmeter what is the potential coming. I want to measure for copper. So just take copper and one side you have to take hydrogen. So like this we will get all the electrode potentials. So there is a table for this, that is your series of electrochemical series is there. So that is done by taking with respect to hydrogen. Okay. So here what you have to remember, that the standard hydrogen electrode potential is assumed to be 0. Okay. So here how the hydrogen electrode is represented, again you have to do the same thing. See, we have a platinum rod. Okay. On that platinum rod we have hydrogen gas, and this one is dipped in a solution containing H+. So how we will represent it? First is platinum, then the gas is H2, and then H+. And the concentration of H+ you have to write in the bracket. Okay. Now what is the reaction? Hydrogen is undergoing reduction, so H++ electron gives you half H2. So till now what all we have covered? We have understood how a cell works, then how to write the cell notation, what is the cell EMF formula, what is electrode potential, and how it is measured. Okay, now we will go to Nernst equation. What is the use of this Nernst equation? First of all we have to know. See, I told you cell EMF formula is E0 of cathode minus E0 of anode. See, this formula is applicable only when the concentration of the electrolytes is 1 molar. Okay. Now, if you change the concentration of the electrolytes, the EMF is calculated using your Nernst equation, right? So, what is the formula of Nernst equation? E0 of the cell is under standard conditions. So, what is standard condition? That is, electrolyte concentrations are 1 molar. So, ESL is equal to E0 of the cell minus 2.303 RT by NF log of concentration of the products divided by concentration of the reactants. So you can see this is the general equation. These all should be ions. Okay. So you have to take the concentration of the ions present on the product side divided by the concentration of the ions present on the reactant side. Okay. So now what else I have to tell here is this value 2.303 RT by F is equal to 0.059. Okay. So we can write this equation as E0 of the cell minus 0.059 by N log of product concentration divided by reactant concentration raised to the power of their stoichiometric coefficients. Here one thing you have to keep in mind is only ion concentrations should be taken. right? Because the conductivity of the solution is because of the ions. Now I'll give you an example how to write. See, Zn to Zn2 plus and copper 2 plus to copper is given. This is Nernst equation and it is how the cell is noted written. So I can write Zn as Zn2 plus 2 electrons. This is the reaction at anode. So always remember left side. Okay, this word you remember lone. Here L stands for left, O stands for oxidation, A stands for anode, and N stands for negative, right? So left side oxidation takes place at anode and the charge of the anode is negative. Now what is it? Anode reaction is Zn giving you Zn2 plus 2 electrons. Cathode reaction is Cu2 plus 2 electrons by Cu. Now you can add these two. We will get Zn plus Cu2 plus will give us Cu2 plus Cu plus Zn2 plus. Right. So in this equation, which is on the product side, zinc is on the product side and copper 2 plus is on the reactant side. So in the equation, Zn2 plus will come in Zn2 plus divided by copper 2 plus will get. Now try for this equation. So all of you can write the equation here. See, by seeing if you do, there is a chances that you may miss the power term. So it is always advised that you write the reaction and then write the Nernst equation. So I told you as nickel is undergoing what? Here nickel is undergoing oxidation. So Ni2 plus 2 electrons and silver is going reduction. Ag plus 1 electron is giving you silver. Now the number of electrons should be same. So I can multiply the second equation with 2. Okay. Now you have to write the Nernst equation. So you add this equation, what I'll get? 2 electrons can get cancelled. Ni plus 2 Ag plus will give you Ni2 plus 2 Ag, right? So in the equation, E will be equal to E naught minus 0.059 by N. So N is 2 here, log of product side, which ion is there? Nickel. So concentration of nickel 2 plus divided by reactant side, which ion is there? Ag plus. But Ag plus you have to you should not forget the coefficient. The coefficient will go as a power of 2, right? So that is how this part is solved. Okay. So now coming to two important formulas. See, Nernst equation is a very important topic, but numericals in exam we get few. So the only thing you have to do is you have to remember the formula. Try 2 to 3 numericals from this topic. Okay, not more than that. Just how to write the equation, how to substitute correctly. So Nernst equation, just practice 2 to 3 numericals. Yeah, but this one is very important topic. You will get many numericals from equilibrium topic. So you can practice 5 to 7 numericals on this formula. Okay. So now what is this E of the cell? We have this equation as Nernst equation, E naught minus 0.059 by N log of product concentration by reactant concentration. Now at equilibrium what happens? E of the cell is equal to 0. So my equation is E naught is equal to 0.059 by N log of this. Since it is in equilibrium, this one we can write it as log K. So that is what is this equation. In many of the questions, you will be asked to find the value of Kc. So you should know how to take anti-log also. So one additional thing what you have to learn here is how to take anti-log values. Okay. So this is one question, and here is this is also one important formula. What is the relation between Gibbs free energy and E naught of the cell? So delta G of the reaction is equal to minus NFE of the cell. Here N is number of electrons, F is Faraday, that is 96500 coulombs, and E of the cell is the potential of the cell, right? So with this, the first part is over. So let us quickly revise once what we have discussed: the working of the cell, okay, and then we have discussed the cell notation. Then we have calculated how electrode potential, right? Then we have discussed Nernst equation, and then these two formulas relating the equilibrium constant and delta G. So from this part, you have to give more focus on this formula. Okay, equilibrium constant questions are asked more. Now coming to next part, that is your electrolytic cell. In the starting I told you there are two type of cells. One converts chemical energy to electrical energy, another converts electrical energy to chemical energy. So in this electrolytic cell, what happens? We will be providing electricity, as a result of which some chemical reaction will happen. So first topic under this is Faraday's law. We'll be seeing quickly what are these laws, and this is very important topic, products of electrolysis. This is very easy and scoring topic. Means if you just remember the products of electrolysis, definitely you can expect one question from this topic. Okay, now let us quickly see the Faraday's first law. So in Faraday we have two laws, first and second. So what happens here? Electrolytic cell, I showed you the diagram in the starting. We will be having two electrodes connected to one battery. Okay, now in this electrode there will be electrolyte will be there. Suppose one electrolyte is there, A plus and B minus. So what will happen in this type of cell? This is positively charged and this is negatively charged. So the positive ions will move towards this side and the negative ions will move towards this side. And I told you at anode it is always oxidation and at cathode it is always reduction. So as a result of reduction, what happens? This A plus will gain one electron and will deposit as A, right? So now if it is getting deposited as A, our task or the questions that we get is to calculate how much mass is deposited. Means suppose what amount of current is passed for some certain time, then what is the amount of mass deposited here. So that is given by Faraday's law, first law. So what is saying? The amount of chemical reaction which occurs at any electrode is directly proportional to the charge passed through it. Okay, so this formula is very important. We have this formula, M is equal to Z into I into T. See, I is current, T is time, that we know. What is this Z and how to calculate? Z is molar mass divided by N, that is number of electrons it gains to reduce itself, into 96500 coulombs. Okay, so I have written it again here, you can check. So what type of questions we get here? We can expect 2 to 3 questions of this type. You can practice just using this simple formula. You have to do some questions. Z will most of the time mass deposited is asked to calculate. So you have to just use this formula and do some numericals from here. Now coming to second law. In second law we'll get very few questions, not very important law. So what does it tell? Suppose you have two batteries, okay? You have two electrolytic cells and you have connected in series, right? So we have connected them in series. Okay, so plus, this is minus, this is plus, this is minus. So now what happens? You have allowed them the same amount of current to pass through these two batteries. So here some mass will be deposited, here also some mass will be deposited. This is anode, this is cathode and cathode. So some mass will be deposited here and this mass will be deposited here. Suppose X is deposited here and Y is deposited in this case. So what does it tell? The mass of X deposited by the mass of Y deposited is proportional to or equal to equivalent of weight of X by equivalent weight of Y. Okay. So M1 by M2 is equal to E1 by E2. Now how to calculate this E or the equivalent weight? Equivalent weight is nothing but molar weight by N factor. What is this N factor? Again, number of electrons used, right? So that is all in the Faraday's law. We'll be discussing numericals. So that is simple. You have to remember practice some few questions from this part. This part is just, if you know the formula, that is enough. Okay, done. Now we'll go to the second important part of the electrolytic cell, that is products of electrolysis. Very important topic. So nothing you have to do, you have to just remember this table. Okay. So we'll go quickly recap this table. If you have molten NaCl, then at cathode we have sodium metal deposited and at anode chlorine is deposited. Reactions no need to remember, just you can see them. You have to just remember the products. Aqueous NaCl, if it is there, this is important. Hydrogen gas is deposited at cathode and at anode we will have chlorine gas. Next, if it is dilute H2SO4, H2 gas at cathode and O2 gas at anode. This question, concentrated sulfuric acid, then H2 gas at cathode and S2O8 at anode. Okay. So again I'll tell you, this aqueous NaCl is important one and dilute H2SO4 is important one. But I'll recommend you remember all the 4 electrolytes products. Okay, so we are done with the type of cells. Okay, now we'll go to the next important topic, that is conductance. From here, most of this whole part, see, I told you from the type of cells, we'll getting more questions from this formula, that is delta E is equal to 2.303 RT log K. This one formula will be carrying most of the questions. So this is the important formula from whatever we have studied till now, and the products of electrolysis. Okay. But this conductance part is having more topics. Let us see them quickly. First is factors affecting ionic conductance, conductivity and molar conductivity, variation of conductivity and molar conductivity with concentration, Debye-Huckel-Onsager equation, Kohlrausch's law, and we have equilibrium constant and Nernst equation. Okay. So now let us quickly see here factors affecting the electrolytic conductance. So you have to just remember some, like it will be like some, what type of questions can be asked here, like 2-3 options will be given, which is a factor, which is not a factor, which of the following affects the conductance. So such type of questions can be asked. So you can just remember nature of the electrolyte, means whether it is strong or a weak electrolyte. Then we have size of the ions, then we have nature of the solvent, concentration and temperature. So just make a key point, write down these 5 just highlighted part only and keep it in your short notes. Just revise these 5 factors. Okay, not very important, yes. Now coming to conductivity and molar conductivity. Okay, so what is conductivity and what is molar conductivity? Understand here. Suppose 2 electrodes are present. Okay, these 2 electrodes, this area, okay, is 1 centimeter, and the rods have a cross-sectional area of 1 centimeter square. Means I can say area of 1 centimeter cube. This area is of 1 centimeter cube. So in this area, whatever is the electrolyte present, okay, the conductance of this electrolyte or the conductivity of this electrolyte present in this area of 1 centimeter cube is nothing but conductivity. Okay, and what is the formula to calculate? K is equal to, what is the symbol for conductivity? Remember this K, or we call it kappa. Then 1 by R into L by A, where R is resistance, L is your length, and A is area. Right? Now, what is the unit for this one? Unit is very important to remember. See, the terms are very, very similar. If you don't remember the units, you may not know which term is given. So one of the way to remember the terms is you know their units. So the unit of conductivity is ohm inverse. Ohm inverse can be written as S or Siemens, right? So S meter inverse or S centimeter inverse. Clear this part? Okay. Now coming to molar conductivity. So molar conductivity is what? Suppose instead there is no we don't have any regulation like what should be the volume. But here one condition is there, we should have 1 mole of electrolyte. If we have 1 mole of electrolyte, whatever is the conductivity, that is called as molar conductivity. And how is it denoted? It is denoted as lambda m, and the formula is kappa into 1000 by C, where C is your concentration. Okay, and the units are your S mole inverse centimeter square. So please remember the units. I'm telling again and again because we have lot of terms which are like conductivity, conductance, resistance, specific resistivity. These are very confusing terms. So remember the units, the terms and the symbols. Okay. So this is done. We have 2 formulas you have to remember. Okay. Next is, now what is this variation part? This is important one. So see here. Kappa, just remember this one, that is conductivity will decrease if concentration decreases. Okay. See, what is, why you just know, can you tell me why? See, I told you whatever ion is present in this 1 centimeter cube, the conductivity of those ions is called as your conductivity, right? Now what happens, suppose I make this, I add more water here. Then these ions will spread. So now what will happen? These ions will move far away. So understand here, suppose we have this 1 centimeter cube area where I was having 5 electrolytes were present. Okay. The conductivity was due to this 5 electrolytes. Now I added extra water. These ions will start flowing. And now what happened? we will have only 3 here, and 2 have gone out due to more adding of more water. So now in this 1 ml, how many electrodes are, how many ions are there? Only 3. So conductivity will decrease because number of ions per unit volume has decreased. So that is why conductivity decreases on decreasing concentration. But for molar conductivity, you have to remember it increases. Okay, it increases due to the decrease in concentration. So this increase is different for strong electrolytes and weak electrolytes. So strong electrolytes, it increases due to the increase in the mobility of ions. So what happens here? I'll explain in very short. Suppose we have NaCl. Okay, we have NaCl. The ions are present as Na plus and Cl minus. Na plus has to move to conduct electricity. Chlorine minus ions has also to move to conduct electricity. Now what happens? Due to the force of attraction, the mobility is less. Now when you add water, okay, when you dilute it means what? Adding of more and more water. So now Na plus is present, here water is present, and Cl minus is present. So the ions have come far away from each other, their mobility will increase, conductivity will increase, molar conductivity will increase. And if we talk about weak electrolytes, suppose one weak electrode is there, Ha, H plus and A minus. Okay, when you add more water, okay, more addition of more water, what does it do? It increases the dissociation of these ions and more H plus are formed. Okay, so number of H plus and A minus increases, due to which the conductivity increases. So let us quickly recap these 3 points. First is kappa value will decrease on decreasing of concentration. Lambda m value will increase on decreasing the concentration. Now why it increases in strong electrolytes? Because of increase in mobility. Why it increases in weak electrolyte? Because of increase in dissociation. Okay, so these 4 points are very, very important. Please note it down, highlight it and keep it. Next, what is limiting molar conductivity? Just we should know what is it. So when we have increased the concentration to a very high amount, the conductivity is maximum, that molar conductivity is called as your limiting molar conductivity. Okay, now here you can see the graph also. This is important graph, such that we will not get any questions from here, but you can just see here what happens. So I'll draw the graph for you. So here we have lambda m, that is molar conductivity, and we have concentration. So this side, when the concentration is very less, graph is like this for weak electrolyte and the graph is like this for strong electrolyte. Okay, so what does this graph represents? The lambda m increases for weak electrolyte is more. The increase in lambda m of weak electrolytes is more. The increase in lambda m of strong electrolyte is less. See here, suppose this was the concentration and now the concentration is decreased here. So what is the increase? You see, this much is the increase for strong electrolyte. But if you compare a weak electrolyte, at concentration this value, the molar conductivity was this one, but when we have came to this concentration, the molar conductivity is somewhere here. So the increase here is more. So that is what is tell that weak electrolytes, the molar conductivity, increase in molar conductivity is more as compared to the increase in molar conductivity of strong electrolytes, but both increases. The reason behind them is because the different in the reasons for that. Okay, so because of strong electrolytes, only the number of ions, only the mobility of ions are increasing, but in weak electrolyte the number of ions is also increasing. So this is very important slide, so please prepare it properly. So what I want to say, let us once again revise. Kappa decreases when concentration decreases. Lambda m increases when concentration decreases. Here strong electrolyte, what is the reason? The first strong electrolyte, the reason is mobility increases. And what is the reason for weak electrolyte? Dissociation increases. So the increase in lambda m, delta lambda m for weak electrolytes is more in delta lambda m for strong electrolytes. The change or the increase in molar conductivity is more for weak electrolytes than for strong electrolytes. See, I have explained everything in this topic which is required for the exam. So please learn these 4 points, very important points. Okay. Now Kohlrausch's law, nothing that much statement and all you don't have to know, just you have to know, suppose one electrolyte is there, MgCl2. Then what is the conductivity of this, molar conductivity of this one? So that is lambda m of Mg2 plus 2 times of molar conductivity of chlorine minus. So what does it tell us? So the total conductivity of magnesium chloride will depend on the conductivity of magnesium and the conductivity of chlorine minus. So this equation you have to remember, we have suppose I'll write one equation for example. You can write it for any one, xy3. So lambda molar conductivity will be equal to lambda naught m of x plus, how many y's are there? 3. So lambda naught m of y. Okay. Now there is another formula too. So where is this an application? So it is used to calculate the molar conductivity of weak electrolytes, and how to calculate the degree of dissociation of weak electrolytes, molar conductivity by molar conductivity at infinite dilution. Then how to calculate the dissociation constant? Dissociation constant is Ka, that is C alpha square by 1 minus alpha. Okay. So no, I haven't seen last from 2000 around 14 till 23. There were no more questions from this topics. So if this is not done is also okay, but not very difficult. You can just go through it. Okay. So I will not suggest to practice any numericals from here. Kohlrausch's law, 1 or 2 numericals you can do. If you leave also okay. Okay, now we have come to the last topic. So till now what all we have completed, let us quickly have a recap. First we have done type of cells, electrolytic cell, galvanic cell. We have studied so many topics under galvanic cell. We have studied 2 topics under electrolytic cell. Second topic is conductance. There I explained you what is conductivity, what is molar conductivity, and the applications and the Kohlrausch's law. Now we have commercial cells. So here we have, first of all you should know what is primary cell and what is secondary cell. Very easy thing. Primary cell, the reaction happens one and it cannot be reused. Secondary cells, the reaction can be reused, like the cells can be reused and the reactions can happen by passing the current in opposite direction. Okay, this is important. Okay, one second. Yeah. So here I want to add one more thing about d by Huckel-Onsager equation. I left it. Let us finish that first. See here, your lambda, one equation is there for this graph. Lambda m is equal to lambda naught m minus a root over of c. This equation is called as d by Huckel-Onsager equation. Okay. So nothing more questions are asked from here, but you should know what is this A. In one exam we have seen a question from here. Suppose I have an electrolyte MgCl2. Okay, so this is which type of electrolyte? It is a 2,1 type electrolyte. Means what? What is the charge of magnesium? Mg is having 2 plus charge, chlorine is having -1 charge. So what will be the electrolyte type? 2,1 type. Okay. Next is, suppose I give you NaCl. What is NaCl type? Na charge is +1, chlorine charge is -1. So it is a 1,1 type electrolyte. Okay. Suppose I will give you, we can write the example of AlCl3. Okay. So for example, AlCl3. So this will be an example of 1,3 type. Right. So we have certain examples for this. Suppose I write MgSO4. Charge of magnesium is +2, charge of sulfate is -2. So it is a 2,2 type electrolyte. Now what is the question asked here? This A value is same for same type of electrolytes. Like for example, MgSO4 and CaSO4. Right? This is also a 2,2 type. So for these two electrolytes, the AA value will be same. Right? Now for example, NaCl and LiCl. Right? For this is also a 1,1 type. So for these two electrolytes, the A value will be same. Okay. So this part we have to do it. Just you have to understand. Once a time this question was also asked. So revise it little carefully. Next topic, that is primary cells and commercial cells. That is primary cells and secondary cells. So in primary cells, the reaction occurs once and cannot be reused. And in secondary cells, the cells can be recharged by passing the current in opposite direction and it can be reused. Okay. So that is the main difference. Next, you don't have to do anything. You just have to know for each cell what are the anode and the cathode. So you don't have to read the reactions also. Just remember, for dry cell, anode is made up of zinc, cathode is made up of manganese oxide and ammonia. For mercury cell, you have to remember the anode is made up of zinc, cathode is made up of mercury. Next, for lead storage battery, this is very important. Okay, this one cell you have to remember the complete reaction. So in anodic reaction, what happens? Lead gets converted to lead sulfate. You can see the charge of lead is 0 here, and here it is +2. Oxidation takes place, and here the charge is +4 and it gets converted to +2. Reduction takes place, right? So this is the reaction during discharging of the battery, when we are using the battery. Now what happens when we are charging the battery? The reaction will be reversed. So this one reaction, remember it properly, write down 2-3 times and remember. And then we have nickel cadmium cell. Here also you can remember anode is made up of cadmium and cathode is made up of nickel oxide. Okay, reactions no need to remember. Again, this is again important, one more cell. Fuel cell also, please remember the reactions, what is happening at anode. H2 is getting converted to H2O and OH minus, like plus OH minus, and we have O2 getting converted to OH minus. So what you have to remember from here? Fuel cell and lead storage battery, right? Okay. Now this slide is there so that you can once read all the symbols and all the units. Okay, so I can tell you, when I was studying, I felt this difficulty. The units, the names are so confusing, so similar. So for that, I have made a table where I have written all the symbols and all the units. So let us revise that once. Okay. So first is your conductivity. Conductivity and specific resistance are the same thing. So in the question, when conductivity what is used, specific resistance what is used, we should not get confused. It is nothing but your kappa, right? The symbol is kappa. Unit is, as I told you, S meter inverse or S centimeter inverse. Next is resistivity. This is rho, or the inverse of kappa. I can write 1 by K is equal to rho. So the units will be just opposite of this, ohm centimeter or ohm meter. Okay. Next is molar conductivity. Symbol is lambda m, and the units I have already told you, S mole inverse centimeter square, or it can be S mole inverse meter square. Then we have resistance. Symbol is R and unit is your ohm. Okay. Next, conductance is 1 by R. Okay, or the inverse of resistance, and the unit is S or ohm inverse. Okay, S can be written Siemens for ohm inverse, or you can write ohm inverse. Then cell constant, that is L by A. Okay, L by A is represented as G star and the unit is centimeter inverse. So you can see, suppose L is centimeter and area is centimeter square. So if we cancel, we'll get the unit of centimeter inverse. Other than that, what symbols you have to remember? Degree of dissociation is alpha and dissociation constant is Kc. Generally, students get confused under degree of dissociation and degree of dissociation and dissociation constant. So these two you have to remember. Okay. So see here, students, what I feel is many students find this chapter little difficult because it has more formulas and confusing terms are there, what I realize. Okay. So my suggestion is just go through this slide, write down all the formulas, make it bold, make it highlight, and all the important formulas I told you. You have to practice the equilibrium formula, Faradays Law formula, products of electrolysis, then commercial cells, and conductance. A lot of questions will be coming. So from conductance part, prepare at least 7 to 10 questions you have to practice. Okay. So the next video will be where we'll be solving top 30 questions of electrochemistry. So you have to complete this one, make it note, write down everything, revise it, and then do watch that video to check how much you have prepared this chapter. Okay. So if you have liked this video and it was helpful for you, so please like, share and subscribe our channel so that you will be getting all the important updates. Your preparation can be developed. So thank you.